Okay, so let's get on with the next part. So we've done 6, I think, which was classification. Now we're having a look at 7. So we're looking to understand the creation, if you like, or development of decimals. So in 7, we have 0.777 repeater, which we can ascertain is a sum of 0.7 plus 0.07 plus 0.007. So our first term is A1. So for an infinite GP, we need a couple of things. We need our first term, which we have, and then we have our R. So we'll take a term and divide by a previous term. I think we'll find that's 0.1. I'll just verify that because we're cautious and we want to make sure. And 0.7, 0.1. So we need to check for the existence of infinite sum, and that check reveals that indeed it's less than 1. So the test for existence reveals the infinite sum exists. So happy days. Alright, so we can use the infinite sum equation to find our equivalent fraction. So we have 0.7 divided by 1 minus 0.1, which is 0.7 divided by 0.9. Now if we multiply by 10, above and below, that's 1 in disguise. That has the effect of moving the decimal place in both terms, so we'll get 7/9. So we can say and that's our position on the decimal, 7/9. So you can see that it's a fairly straightforward thing, I think, once you get the hang of it, how to do it. So 12, 12, 12. And it's just a case of the repeating, providing the spaces. So there we only had to do by 12, by 1 decimal place. Here we'll have to probably do more. 0.121212 ... is equal to 0.12. Now we need to be careful here because we need to leave 2 decimal places, 2 zeros. So 0, 0, 1, 2 will get us the second pair, and then we need to do it again, 0.4 zeros, 1, 2, to get our final part. So we need to then just go through the same process. Our first term, 0.12. R is, take a term and divide it by the previous term. So we can check to see it, just because we're cautious. .01, and we can say by testing for existence that 0.01 is indeed less than 1. So yes, if it exists. So we can go ahead and do our sum. So A1 is 0.12 divided by 1 minus 0.01, 0.12 divided by Just use your calculator. Don't try and do everything in your head. Minus 0.01, 0.99. And so we can move the decimal place twice by multiplying by 100 over 100, which is 1. So we don't change the proportion. And so we get a fraction of 12 over 99. So our 0.121212 is equal to 12 over 99. So it's just a great way to decide them, isn't it? Great way to work them through. 0.47. So 0.474747. We'll have a first term, a second term, a third term, and so what we can do is then understand that it's infinite series. There's a first term, and our R will be to take a term divided by the previous term, and believe it or not, you're going to get the same thing. So when you do these a few times, you'll start to recognise 0.0 as a proportion. It's the same thing, not 0.01. So I won't write all the other stuff up, but the sum to infinity will be equal to 0.47 divided by 1 minus 0.01, 0.47, 0.99. So then we get times by 100 over 1, 47 over 99. There it is. Okay, very good. Alright, an infinite sum. In an infinite GP, the first term is 2, and the sum to infinity is 8. Find R. So we get the first term is 2. The sum to infinity is equal to 8. So the way that we would set this up, we would write 8 is equal to 2 over 1 minus R. That's just a case then of multiplying clearing fractions. So 1 minus R, both sides. Now because of the algebraic requirement, you need to group them in a bracket. So that'll become an expansion on that side, that will cancel. So we'll get 8 minus 8R. So now we've isolated it to some degree. So we can subtract 8, I think will be okay. So minus 8R equals minus 6. And divide by minus 8. So R will be equal to positive, because minus over a minus. And that'll resolve to 2 by 3 and 2 by 4, won't it? So they'll cancel, so you'll be left with 3 on 4 as your R. Okay, so just keep on moving on here. Just make sure you read the questions and make sure you can follow the questions through. That's the most important thing. Consider the infinite GP, 1 plus R squared plus dot dot dot. If the first term is equal to the sum of all the terms that follow it, find R. Ah, okay. So that's a bit tricky. How are we going to express that? So 1 plus R squared plus dot dot dot. This says, doesn't it, the first term is equal to the sum of all the terms that follow it. Well, the first term's 1. So all the terms that follow it sum to what? 1. So that plus there is effectively adding 1 plus 1. 1 plus 1. We get a 1 plus a 1. So the sum to infinity for this particular GP is 2. Yeah, is 2. Now, we know our equation is A1 over 1 minus R. So we can populate the values. 2 is equal to 1 over 1 minus R. So now we're resolving for R. So that's a bit of a trick, isn't it? Sometimes you'll get wordy problems. You might not be able to pull that out without having had to go at a few different things. So with clear fractions, same as we did just a little bit earlier, make sure you put the bracket and do the expansion. They'll cancel. So we'll get 2 minus 2R is equal to 1. And we can put the 2R over. You could have made it plus to make it a bit easier. Plus 2R. But you've just got to be careful that you don't forget anything. Okay? So then subtract 1. So 1 equals 2R. Okay? So then we've got to divide by 2. What you do to one side, you do to the other. So therefore R is equal to a half in that particular problem. I'm pretty sure that's it. R is a half. All right. So for the last one, we want to find the difference between the sum to infinity and the sum of the first 8 terms. Wow. Okay. So the sum to infinity and the sum to the first 8 terms. And our series is, I'll just do this way. Plus 164 plus dot dot dot. So A1 is 256. R is going to be the same for both terms. So we're going to take a placeholder and divide it by the previous one. Okay, or take a placeholder and divide it by the previous one. Okay, and you can clearly see that that's going to be a half. Okay, so we're going to have an R is a half. Then we're going to have an infinite sum. So this also passes the existence test. Half is less than 1, so the existence in infinity does exist. So A1, 1 minus R. So we get 256 divided by 1 minus a half, which is 256 divided a half, which is 256 times 2, which is 512. Okay, I think. Alright, the next thing we want to do is consider the sum of the 8 terms. The sum of the 8 terms. So for the sum of the 8 terms, we need to use the partial sum equation. So I'm just drawing your attention to it. And the partial sum equation sits up here. And there's our partial sum equation. So A1, 1 minus R to the n over 1 minus R. So A1. So I'll put it over here. A1, 1 minus R to the n. 1 minus R. That's your partial. Okay. So for us, for 8, we've got 256 bracket 1 minus now a half to the power 8 divided by 1 minus a half. So we get 256 1 minus, what do we say? 1 to the power 8 is 1, and 2 to the power 8. We've done it before. 2 to the power 8. 2 2s are 4, 2s are 8, 2s are 16. 32 is 5, isn't it? 1, 2, 3, 4, 5. 64, 128. 256. 1, 2, 3, 4, 7, 8. 256. That's 1 over 256. And 1 minus a half is just a half. So that's everything times by 2. So I'm going to multiply the 256 by 2, which will make it 512. And we've got to do 256 families. So 256 over 256 minus 1 over 256. So it's going to be 255 over 256. Okay, so we'll work that one out. Done everything right there. 512. I haven't used technology at all to check this. So what did we say 256 was? 2 to the 8. 2 to the 8. So that'll be 2 to the 8 times 2 over 2 to the 8. I'm just playing with these now. So they'll cancel. So it's 2 by 255s. 2 5s are 10. 2 5s are 10, 11. 2 2s are 4, 510. Okay, so the difference between them, minus S8, is 512 minus 510, which is a difference of 2. So that's your final answer. Alright, so hopefully that's been quite helpful, and that was what we did for sequence and series.